Okay, so thank you for having us here this evening. We're here to present to you an overview of the methods and results of a project we've been working on with the staff of LAMO on Ramsey County Ditch 14 public drainage system, also known as Lambert Creek. I'm Nancy Stowey. I'm a water resources engineer with Houston Engineering, and I served as a project manager on the project. Alex Schmidt, the tall one in white, is a project engineer. He did a lot of the heavy lifting on this project. And Chris Otterness, his role was an advisory role. He's also the district engineer for the Rice Creek Watershed District. So he kind of kept us on the right track as far as the regulatory aspects of the public drainage system. And he'll briefly discuss that this evening. So just a figure to get us oriented. Showing where the County Ditch 14 lies within the LAMO watershed, as well as its local subwatershed. And so what we're going to discuss this evening is we're going to provide you some information on the condition of County Ditch 14 with respect to its establishment, the regulatory environment, and its current condition. And then in the end, we're going to provide you with some management recommendations for the future. So why is this important? County Ditch 14 was constructed over a century ago, and it was, of course, originally designed to serve agriculture. But as any aging system, it's very likely that its capacity has decreased due to sediment accumulation, trees falling, maybe channel banks falling in, reducing the capacity. But then at the same time, the flow and the volume it needs to convey the water is increased due to the changes in land use, and specifically to urbanization and the resulting increase in impervious surface. So there's a lot more runoff coming in it than it did when it was constructed. So it was actually a really good idea to evaluate the capacity and the demands on the ditch. Look at the current ditch depths as well as the capacity and the peak discharges going through it nowadays, as well as the high water levels. And this information then will lead to identification of problems to solve. So today's discussion, this is a brief outline. Chris is going to first come up and share some information on public drainage systems and processes. Alex will then share what he discovered through an historical review as well as results of survey data collected along with the staff of LAMO. And then we'll share the results presented in a repair report that we submitted to the district or to LAMO. And then we'll provide some recommendations and next steps and then finish up with questions and discussion. So right now I'm going to exchange places with Chris.
So I'm going to talk a little bit about what exactly a public drainage system is. And really when I'm talking about that, I'm talking about these agricultural systems. Most of them were constructed back at the turn of the 20th century. Some of them were even before that, early I should say late 19th century. A lot of the local drainage systems around in Anoka and Ramsey counties were constructed back then. But these are systems that are located all across the state. Most of them are still in existence, still being utilized for various different purposes. But in the original purpose for these systems was to be able to drain agricultural lands. And one side purpose for that that's stated in numerous documents way back from 100 years ago was the idea of actually doing this work to drain wetlands in order to decrease the mosquito population. That was one of these side reasons that they used them back then. Of course, these reasons for having the drainage systems can change over the years, but all these systems are subject to a Minnesota state statute called 103E. And this statute has been in some form for over 100 years. This is the mechanism that they originally used to establish these drainage systems. And the idea back then was a bunch of farmers that get together and say, we want to have a system that's going to be able to drain our properties and have some sort of consistency to it and reliability to it. So then they would petition a county or Sometimes if it was multiple jurisdictions, like say cross county lines, then they would actually petition to a judicial authority, and whereby then they would have hearings and they'd appoint engineers and go through a large process to determine whether or not the system would actually provide benefit more than what the cost was originally. And then they would assign benefits to the system and assign damages for people that would be damaged by the construction of the system. And then when this project would be ordered back then, either be ordered by a county board or ordered by a court and through a judicial proceedings, if there were multiple counties that were involved, then they would go about constructing the drainage system, and people would then have to pay in assessments in order to get it constructed. And because these people paid into that system, they still, even to this day, have some right to drain. It might not be to the degree that it occurred back in the early 20th century. In a lot of cases, changes either in climate or changes in land use would prohibit the system from being able to even have a similar function or capacity that it did back then. One example, of course, would be this county ditch that we're talking about right now, County Ditch 14. A lot of changes, as Nancy alluded to earlier, in the landscape that increased the amount of runoff going to the system and the performance of the system. But again, it's important to understand that these systems, even though they were done 100 years ago, these documents that we had from back in the day, they're still valid, they're still in use, and Alex will talk a little bit more about that later. One of the main ideas about these systems is that there was a authority that managed the system when it was originally constructed, and subsequent to that, there was always some sort of an authority, it might have changed over the years, that was in charge of maintaining the systems on behalf of the benefiting landowners. And in this case, it would have started off as a county ditch, as Ramsey County. Sometimes they got transferred to a watershed district, if there was a watershed district over the top of the drainage system. And of course, in this case, it ended up getting transferred to a water management organization, the VLAMO. One important thing to note is that the counties and watershed districts that were assigned this responsibility, they are the only entities that can be drainage authorities. So even though I said now that the system has been transferred to VLAMO, the water management organization, in its capacity, it does not have the ability to be a drainage authority. And I'll get into that in a little bit, but it changed what statute now under law that the drainage system is actually being viewed under. It started off as a 103E system, meaning public drainage systems. Now the water management organization actually utilizes its authority under 103B, which is for municipal water management organizations. But they still act as these, the original drainage authority does, in being an executive of the system on behalf of the benefiting landowners. Those people that paid for it originally, they are the ones that receive the benefit for it. They are the ones that paid for the system, and therefore the drainage authority is responsible for acting on their behalf in their interest when they're wearing their drainage authority hat on that particular day when they're making the decision regarding these systems. So I'm talking a little bit about VLAMO and their role in the system. Again, they were transferred to the authority of the county ditch back in 1986. So it's been a number of years now. There aren't many of these drainage systems that have been transferred to a water management organization like VLAMO. In fact, they might be one of the only ones in the state that I'm aware of that was transferred to this authority. And it was transferred under state statute 103E 8112, which says that after the transfer of a drainage system, and that can be to any sort of municipal water management organization, to the Water Management Authority, the drainage system ceases to be subject to regulation under this chapter, meaning statute 103E. So that, as I said earlier, the authority now is under a different state statute, 103B. However, it's still a good practice, and in some cases a necessary practice, to follow the original state statute for public drainage systems. And there's a few reasons for that. One, the nature of the system, even though it's providing a different purpose now, it's not for agricultural drainage, but it's actually more of a municipal outlet. It's still a ditch, meaning it's still going to function in a similar manner. It's going to have similar issues with regard to maintaining the system, be able to have water flow the way it needs to be. And there are going to be some similar needs for the system that are related to any other public drainage system. In addition to that, there's going to be regulatory requirements that are going to be similar for public drainage systems, or what I would refer to as non-public drainage systems, these systems that are under a different kind of authority. And some of that is the state wetland law, which is the Wetland Conservation Act, and also federal laws, including the Clean Water Act. These are two different laws that govern what a drainage authority can and cannot do in doing maintenance to the system. They provide some bounds, and there's some engagement that needs to occur with those authorities in order to be able to conduct repairs under certain circumstances. So I'm going to talk a little bit now about why you even maintain the system. You have this old ditch that's sitting out here, again, 100 years old. Why does it even need to be there? Well, for one thing, it's now serving as a outlet for a whole nother land use out there, the municipal land use, and it's really serving as a stormwater outlet. And if that isn't there, it's going to create issues because of the infrastructure that's been built out on the landscape, including some dams that are out there, culverts, roadways, even people's houses is dependent on having that infrastructure there to be able to get the water out. If that wasn't in there, you'd have water flowing in different directions. You might not have any sort of predictable amount of how much water is going to be coming through the landscape. And that's a key word, is that having that predictable drainage. Everybody that's a landowner adjacent to the system is going to want to know how it operates so that it isn't bouncing up 3-4 feet up and flooding your house out under certain rainfall events. And we don't want how the system and how the water levels occur on the system to change drastically based upon a condition that's changing with regard to the system. And that's why it's important to be able to maintain these systems and provide that predictable drainage. And it does fulfill a responsibility that is required under Minnesota law. Another part of that statute that I referenced earlier that transferred the drainage system from the county over to Vlamo states that the transfer drainage system shall become a work and a responsibility of the transferee water management authority. So it's stated right in statute that the water management organization is responsible for the system, has that duty to provide inspection and maintenance of the system. So if we are going to look at doing inspection maintenance of the system, how do you go about it? Well, we like to utilize this graphic here that shows the steps that are related to managing one of these systems. And it can be a system that's way up in the Red River Valley, a system that's, a tile system that's over in Renville County, or it could be a system that's, in the North Metro. They all have the similar kind of function and process of how you manage them. It all starts with knowing what kind of records you have in the system, because that actually helps set a bounds for not only what you have the authority to do, including what kind of regulatory engagement you need to be able to utilize, but what kind of, duties and responsibilities you have with the system. And so again, as I mentioned before, even though these records are over 100 years old that initially created the system, they're still valid yet today, and they're still important to know with regard to how you're going to manage the system. Next thing you got to do is be able to do inspection, be able to prepare reports, and that's one thing that we'll be talking about a little bit, is our repair report for the system, determining what the condition is and how it might be fixed. Third item that's always important is who's going to pay for the project, and that's something that will be another step that's required in the process. It requires certain deliberation of what kind of policy you're going to have with the system and what kind of regulatory process you're going to be going in. And then finally, once you've gotten all those things done, then you can begin your project. But you can't start going out and doing work on a project without getting those other 4 items in a row so you know what you're dealing with. So I'm going to talk a little bit about some terms that you'll be hearing Alex and Nancy talking about in a little bit. Just for a little bit of clarity, when we're talking about these things, maintenance and repair, sometimes we use these synonymously. Basically, we mean fixing the system, and this could include cleaning out the ditch by doing excavation. It can be creating a corridor and be able to create access to maintain the system, or it could be replacing culverts, those kind of things. But those are generally things that are done to keep the system functioning as it was originally designed, or some function that it's provided since then. If we're talking about the word improvement, and that's a very touchy word because it's utilized a lot of time in state statute, that means making the system actually bigger, deeper, steeper than what it was when it was originally designed. And when you get into using the word improvement, that gets you in a whole different regulatory category, both with state laws and with federal laws. And then one of the other terms that you hear a lot as we're talking here is this term as constructed and subsequently improved condition. And what that means, again, is that there are certain lawful things that occurred from when they originally ordered the project and ordered the construction of the drainage system 100 years ago, and any sort of improvement that occurred along the way. And there actually was one improvement that occurred that Alex and Nancy will talk about. Those things establish what the baseline is for where you might be able to excavate to, or the kind of level of maintenance you can provide without getting into a different regulatory environment, having different kind of restrictions upon what you're working on. It's very important to know that now, because you don't want to get out there and start digging and then find out, oh, I've gone too far and now we're in a position where we're in trouble with the regulating authorities. So with that, I'll turn it over to Alex. He could start talking a little bit about these records that I mentioned and how we're utilizing and evaluating them.
Thanks, Chris. Yeah, so this is, what did we actually do in our project, right? So we'll start off. This is the historical review. So the purpose of it is to reestablish the public drainage system record. And what does that mean? We wanted to look at how does this system originally established with these historic documents, and then review any changes, modifications that have been made to the system, and that leads you to what is the system at today. And so we go out there with the survey crew and determine the alignment and the profile or the elevation of the system along the ditch. And finally, kind of the key of it is determining the as constructed, subsequently improved condition, which we'll talk about more. Chris just mentioned it, but it's the baseline for future maintenance or repair. So here's just a snapshot of some of the documents we found. They're dating all the way back to 1916, which was when the ditch was established. And you may think, well, how do these old plans still have any impact today? And they are all still relevant in the regulatory and management world of public drainage systems, as Chris was talking about. So the history of CD14, well, I said it was established in 1916, and then we have a document from 1926 that shows the actual profile and elevations of the ditch, along with some other culverts that were originally installed. And that was a key document in determining the as constructed, subsequently improved condition. 1986, the system was transferred to Vlamo from Ramsey County. 1987 was kind of a milestone project engineering report that recommended a lot of the weirs that we see on the system today. Of course, there's a lot of other major modifications to the system with all the development occurring around it. I'm just showing a few here. But to step back a bit, this is, the CD14 system, also known as Lambert Creek in many of its locations, located in Ramsey County, in the city of Vadnais Heights, White Bear Township, and White Bear Lake. And it consists of the main trunk, which heads down the middle of the map here, as well as 5 branches that are all spoking out the sides of the main trunk. And so we reviewed these documents, determined modifications to the system, and you can see in orange on this map that that was the ditch as it was originally constructed. And since from our survey, you can see in the blue-black dashed line where the system and where the ditch stands today. So we found that out through our survey. And here's just some photos of HEI staff and Vlamo staff. Brian and Tyler were instrumental in chipping through much thick ice to get all of our survey shots. And they also educated us on the system as we went through and showed us the details of the in and outs of the ditch. From the survey, we can then plot, plan and profile drawings of the system. So this is a profile drawing, meaning the cross-sectional view, the long ways on the ditch. And you can see, if maybe you can see this dashed line is the existing ground that we surveyed with some culverts. And then there are these black dots that you see, and those are soil probes we took. In the soil probe, we take the survey rod and push it down through the accumulated sediment to a depth of refusal. And once you hit either clay or sand, it's a good indicator of that's where the ditch was originally constructed. And so that will help determine the as constructed subsequently improved condition, which is shown here as this black straight line. And so those black dots correlate fairly well with the as constructed subsequent improved condition. One other thing I'll mention about these profile drawings, well, we use them to look at the system in more detail. We can see any improvements that have been made on the system by comparing old documents. We can see any impoundments made on the system. That would be a lot of the weirs that are along this, as well as what you see in the red there, any accumulated sediment through the ditch. And Nancy will be hitting on that more in the repair report. I just want to give you a couple examples of some of these alignment changes that we've seen. First, here is a culvert, and now in green here, you'll see the as designed alignment, and in the blue-black is again the current. So a culvert along County Road F was installed, I think, in the 70s or maybe the 80s. And you can just see the alignment change from the original as designed alignment, and also more recently the Lambert Weir project realigned the ditch. Another interesting thing we found was you can see branch 1 in orange here was originally thought to be the main trunk, which was sort of made sense as a lot of the water flows through this ditch. This is on the very upstream end of the system. And it was found that in the original documents, this portion of the ditch was called branch 1, not the main trunk. And so we've corrected the system to say the main trunk is actually this portion going north here in Rice Lake. This map shows another interesting feature, that the public drainage system actually ends somewhere in the middle, a couple hundred feet east of Rice Lake. And so there's this portion of clearly a ditch that we went out and surveyed that is may require some further investigation to see what who has the authority for it, who can access it, who's going to maintain it. Last part of the historical review was just identifying problem areas that we found along the system. First, there's high water concerns along Pennington Place that we were very cognizant of as we surveyed and did the report, and Nancy will get more into that. This picture shown here is Lambert Weir. which was designed to treat water by dispersing it through the wetland. And that is sort of defunct now, and it's short-circuiting along this ditch here, along the sheet pile weir, and not dispersing through the wetland for any water quality benefit. Second, there's many footbridges along the system, some of which are in disrepair, so they could block or impede the flow of the water. And finally, there was a couple locations with fallen trees that were also in the conveyance path of the system that could block water as well from flowing downstream. And I believe some of this may have been maintained already. So with that, I'll invite Nancy back up to talk about repair and recommendations.
Great, so thanks. So the process continues once we now understand the historical development of the ditch, and we know what the as constructed and subsequently improved condition is. That's, basically the profile to which we can repair. We cannot go below that, right? But we move on to the repair report, which is what regulatory calls that next process. And the purpose of that report is to identify the problem areas, okay, and describe potential repairs. And we did this along the main trunk of CD14. And what that all includes is first of all, a hydrologic and hydraulic evaluation of the system, and that's to identify problems that maybe aren't seen while they're out there inspecting and doing the survey. Then analysis of the possible repair alternatives, for which we then develop cost estimates and then recommendations based on these findings. So starting with the hydrologic and hydraulic analysis, what we do there is we will take all of the geometry data that we got during the survey, and we're going to build a computer simulation model. And we do that we can do it with various models. We use a proprietary software called XP SWMM. And we build this computer model, and it simulates, therefore, the existing conditions. And then we can find out where are, extreme high water, areas that may be encroaching buildings, any other problems. And once that's established and simulates the existing conditions, we identify problem areas, we can stick in repair. Let's say you want to replace a culvert. We can put a culvert in there, and then we can see how everything changes. That's why we build these models. Anyway, so model results. So one unique aspect of the CD14 system is that much of it is actually controlled by engineered weir structures. And I can't see this very well, but we have the Rice Lake weir, we have the Grass Lake, and the Lambert weirs. And they kind of control the elevations upstream a lot. And luckily, no homes were found at risk upstream of these weirs, and actually no homes were found throughout the entire main trunk system that are actually at risk of being flooded in the 100-year event. And when I say 100-year event, I mean that rainfall event which has a 1% chance of occurring in any given year. And that's simulated with 7.3 inches of rainfall. Okay, and that rainfall event occurs within 24 hours. And although we did find one garage up in this area around Branch 3, just south of County Road F, that is at high risk of inundation in that 100-year event. That's the only structure that we found. We did find around Pennington Place, there are homes. We surveyed all of the low floor openings of those homes, and we found that the 100-year high water levels, they are not within 1 foot. They are within 2 feet of some of the homes, still within, FEMA safe criteria, but it's just something to keep an eye on. We don't want the drainage in the system to get any worse, right? It's a good reason to maintain the system. So we also simulated the 2-year event, which is often considered a benchmark for frequent rainfalls. And that is the event that has a 50% chance of occurring in any particular year. And we simulate that with 2.8 inches of rainfall in 24 hours. And what that did was confirmed that there is a definite encroachment of the floodplain into the yards at Pennington Place. So that's what we did with the 2-year. And I just want to note, though, we simulate that in the computer model. We also assume that the ditch has drained between rainfall events. In reality, what the residents could be experiencing is that if the downstream ditch is not draining properly, it may not have receded completely before the next rainfall event comes along, right? So let's say the ditch actually in reality is starting a little bit higher, the next rainfall comes up, so that high water level, at times could be higher, and that could compound itself throughout the season. So then, once we identified then a potential problem in this area, we begin to look for the potential causes. So we look downstream of Pennington Place. And what we found, or what actually Alex and Brian and Tyler found, is downstream about this location, north of Kohler Road. They noticed trees within this channel, which could be, affecting the drainage. And they also found in this area some undercutting and bank erosion just downstream of the confluence with Branch 5, which, could potentially cause sediment to build up in that location underneath or at the bottom of the ditch. And indeed, if you look at the drawings that we made here, you can see that there is 1 to 2 feet of sediment buildup in actually both of those locations. So it definitely could be a cause of our issues. So before we actually jump into what repair alternatives we're going to select, we need to step back and figure out, make sure that we're actually figure out what problems we're trying to solve. And I just want to review again what we did. We first always start with looking at structures and structures at risk of inundation in the 100-year event. We found that this is not a problem throughout the system. We found 1 garage that is prone to flooding. But we also found that there are no repairs that we would be able to carry out that would actually improve that so that it would be completely free of that risk. Then we also looked at nuisance flooding, and that's backyard flooding in a 2-year event. And yes, there are repairs that could make a difference and help that situation. It won't prevent all nuisance flooding, okay, if we're staying with a repair and not moving to an improvement. You can help the nuisance flooding. It's not going to remove it completely. And again, I guess we confirmed that nuisance flooding that's been reported by residents in that area. So we came up with 2 alternatives. Alternative 1 consists of removing the accumulated sediment for about 4,300 feet of ditch, starting here just upstream of Pennington Place where the sediment starts to build up significantly, all the way down through Edgerton and Kohler Road, and down to this point at the end of the orange line. So this would, again, basically include lowering the flow line of the ditch to the as constructed and subsequently improved condition. So this would actually reduce the 2-year single event flooding by at least 0.15 feet. And the reason I say that is, again, the existing conditions analysis assumes, water is starting at the bottom of the ditch, right? What this will also do is it'll help the ditch drain all the water that's been accumulated between storm events, so that the next time a rainfall comes, it's going to start fresh and the ditch will be, drained down to its normal water flow. Alternative 2 takes it a step further. It still has a ditch cleaning for this 4,300 feet, but it also replaces the 54-inch culverts at Edgerton and Kohler with 60-inch. This is a much more expensive endeavor. It is $352,000 as opposed to the $105,000 for the alternative 1. It will reduce the 100-year by 1/3 of a foot, but it still doesn't take that 1 garage out of the floodplain. No, so that .28 is the difference between the existing conditions high water level and the proposed conditions high water level. So, and so that would be different, right? So when, in the second repair, when we increase also the size of the culverts, so we increase the flow capacity more, then the high water levels upstream will go down more. Okay. I'm going to move on to therefore the recommendations. So we had those two alternatives. So repair alternative 1 does address the nuisance flooding by decreasing the depth, duration, and extent of the flooding. However, even though alternative 2 does reduce the flooding quite a bit, the difference in cost of $247,000 is a lot. And so we probably wouldn't recommend immediate action on alternative 2 right now. And we're recommending that the board consider looking at alternative 1 because it is to address nuisance flooding as opposed to structures flooding. It's not, there's no urgency to safety right now, but we do recommend that they look at that and consider it potentially for the next couple of years in their budgeting. And we also recommend that they start talking to contractors. That area is going to be very difficult to access. There's some real deep areas. And so to start talking about the feasibility of how that could be done, to start talking to landowners and let them know, that the ditch is there, that a repair of the ditch may impact trees, okay, and may impact, some parts of their property if they need it for access. And I think I'm going to leave it there. And we are going to, so I'm going to go back to, this was Chris's original drainage system cycle. And so what we've completed so far is the records. We've included this inspection, which includes the repair report. And the next step will also be looking at financing. So if the board decides to move forward at any point, the next step will be look at getting a cost estimate a little bit more refined after, going out for bids for, with contractors. And then, working on any permits if we have to deal with the DNR, and eventually construction of the project. So again, if they do consider ordering the repair, budget for the project, develop scheduled timeline, regulatory engagement with landowners, develop project plans, and construct project. I got it. Okay.